Hey everyone, welcome to this video. In this video, you are going to learn the different types of connection we are going to be made in the resistor. Okay, so in this previous video, we had discussed about what is resistor and what are the types of resistor and how it is actually working in the Ohm's law. So all has been discussed. So through that, how we can able to connect the different types of connection we can able to make with the help of the resistor. Okay, so first of all, in this video, completely you're going to be learn about CD circuit, parallel circuit, and voltage divider. Okay, so these three concepts you can clearly understand about the logic. Okay, first of all, if I'm going to be connect the resistor in series. Okay, for example, I'm going to be take the two resistor. You just simply see this one. Okay, so this two resistor have been connected in series. Okay, so if I'm going to be connect this resistor in series, what will be happen? Okay, what the changes we can able to fill, whether the voltage will be changed or current will be changed, kind of thing we are going to be discuss. First of all, we will see the fundamental characteristics of this one. Okay, yeah. So when I'm going to be connect this resistor in series, okay, just take one breadboard and one after another, when you're going to be making this connection, it is going to be act as a series. Okay. So, and what about this parallel circuit means? So whenever we just making any load, okay, in between this resistance, that is going to be act as a parallel circuit. Okay. So that is the difference of this one. So first of all, main important thing you are going to be learn it is, so when I'm going to be connect the resistor in series, okay, I'm checking two resistor, okay, I'm going to be connected in series manner. This is the R1 resistor and this is R2 resistor. What will be happen? Okay, so this is what we are going to be discuss. Okay. And first of all, when I'm going to be connected and see single current path will be going to create. The current is the same throughout all the component. Okay. So whenever I'm just giving the voltage, somewhat I'm going to be give some 5 volt. Okay, just take it 5 volt. Okay. And I've started to give the power supply. And what will be happen is the electrons will be started to creating. Okay, the electrons will be started to move. At the time, the conversional current will be started to move from high potential to the lower potential. So with this concept, we have been clear. So always the electrons will be started to move from low potential to high potential. This the conversional current moves to the high to low potential. So whenever it just started to move that, you can able to see the same amount of current only move throughout this circuit. Because why? Because it is the only single direction. Okay, it is chooses the only single direction because it doesn't have any multiple path to be chosen. When the current is started to move, it is only have this only single direction. Again, it will be move. Okay, so whenever we apply some power, will give some voltage, the electrons will be started to move. At the time, the current started to move to the high potential to low potential. So it is in the single direction. So what you are going to be understand here, it is in the single direction path, the current remains same throughout all the components. So even the current is same in R1, R2, and other components. Why? Because it is single direction. And what about the voltage? Voltage will be drop. Okay. So, how we can easily understand this concept is, so you just take one pipe. Okay, you just simply take some pipe. Okay, so in this pipe, you are just having a, potential. Okay, you are just having a, potential. Okay, so it is a single line pipe. Okay, it is a single line pipe. Okay, so you just giving the potential is your water tank. Your water tank is your potential. That means your pressure you're trying to give. Okay, so if it is a single line, you are just trying to give, for example, you just take a liter of water. Okay, you're trying to give about 10 liter of water. So 10-liter amount of water, you are just trying to give through this one hole. Okay, you are just apply the amount of water that is a 10 liter of water or liter of water started to apply. And what will be happen? So the 10 liter of water will be same throughout the pipe. Okay, at end you can same 10 liter of water only you can able to acquire it. Okay, why? So now you are going to be consider this water, 10 liter of water is your current. Okay. So if it is a single line pipe, how much amount of water I'm just entering into this pipe? Okay, how many number of how many liter of how much liter of water is entering into this pipe through this, it will be same. So you can able to attain the same 10 liter of water because it is a single line. It can't able to move in between any of the holes or not. Okay. So, and what will be changing here might be the pressure will be changing here. Okay, if for example, if it is the same line of pipe, okay, it will be cool. Okay, not going to be changed. You just think about it. If it is having some of any changes in the pipe like this, okay, if the changes in the pipe like this, in minute changes, it will be affect the pressure. Okay, the pressure will be changing. Okay, so what you're going to be understand here it is, so whenever you have been connected the pipe or serial, okay, it will be suited in your connection also. So whenever you're going to be connected in resistor in series, what will be happens? So series connection, it's completely made up of it is single line. Okay. So at the time, it will be only flow, the current will be only flow through the only one direction. How much amount of current you have been giving? For example, 0.5 milliamp of current, it will be started to produce, means that same amount of current only started to producing complete the circuit at the end of the circuit. So, if what actually going to be changing, the potential going to be get changed. For example, if you're using a high resistance value, for example, here you have been using a 10 ohm. Okay, for example, and here you have been using a 20 ohm. So, what will be changing? The voltage only get dropped. Okay, so here you are going to be consider the different voltage value. Okay, so here the voltage drop is, if it is a 10 ohm, voltage drop is less. If it is a 20 ohm, means it is the voltage drop is slightly high. Okay, so whenever the series connection, you just keep it on the mind. You just this take this example of pipe. Okay, how much amount of water you just push to give into this pipe, the same amount of water only you can get outside. Okay, so that is going to be changed. So because of this pipe size, so whether it is having the different size, it is any changes in the size module. So that time only the pressure is get differ, but what amount you have been given inside this pipe, the same amount you can able to get into this outside. Okay, so in the series connection, it was going to be changed, not going to be changed. Okay, so that is the important logic we are going to be understand in this series connection, guys. Okay, now we will see the very good example for the series connection. We will have some one draw some example. Okay, how the series connection is going to be work. Okay, I'm just using this every circuit website, so I'm going to be show that when I'm going to be connected the resistor in series manner, how it is actually going to be working. I'm just opening the new circuit. I'm just simply taking a two resistor. Okay, just simply taking a two resistor. So, and after that, I'm going to be trying to apply some voltage. For example, I try to give up to 5 voltage. Okay, 5 voltage. Okay, and finally, it has been grounded. Now, I'm going to be give this connection. Okay. Yeah. So here, what I've did here it is a series connection. I've made the series connection of resistor. So both resistor has same value 1K, 1K resistor. Okay. Here the thing we are going to be concentrate is the resistor has been connected in seriously. Okay. So when I'm going to be apply some voltage, what will be happens? Let's check. Yeah. Here you can able to see it clearly, guys. So here I've been applied 5 volt. Okay, you can able to see that whenever the current is crossing this line, electrons have started to move. Okay, at the time current is produced, and this time when it is crossing this line, the voltage just get dropped. Okay, because of this resistor we have been provided, it is a 1K ohm resistor. It just reduce the potential of this current. Okay, so at the time you can able to see how much you can able to, it is 2.5 volt. Okay, it has been dropped to 2.5 volt. Okay, again when it is crossing this line, some amount of voltage has been dropped here. Okay, again it has become 0 volt. Okay, when it is dropped to 0.5 volt, whenever it is causing this line, so it has been reduced for 0 volt. Okay, at it meeting this line, so again it will be started from 0 volt. So after we are just giving the 5 volt, again the 5 volt is started to give the pressure, so current is flowing, so it is happening continuously. If you are going to be check this current value, it still remains same. It is 2.5 milliamp of current has been same 2.5 milliamp of current is, even though I have been applied the 1k ohm of resistor, 1k ohm of resistor, the amount of current this remains same in the series connection. Okay, for example, here I'm going to be change the resistance value up to 2k. For example, 2k. Okay, what is happening here? You just see that, yeah. So now when I'm going to be changing the resistance value, okay, I just simply changes the resistance value. The amount of current, you can able to see that here also 1.67, here also 1.67. So but same entire, so if you are just it is going to be taking this two resistance value. Okay, it is going to be checked that it is totally 3k kilo ohm, so it depends on that the amount of current you can able to finally fix it. Okay, it is the value of 1.6 milliamp of current. Okay, so depends on this two resistance, it is going to be calculating the value. So the total resistance up to 3 ohm it is there. Okay, and depends on this Ohm's law, we are going to apply this formula again, we can get the constant current. That constant current is still same in this entire circuit. You can able to see this, it is 1.67, 1.69, even though we have been putting the different resistance. But if you are going to be check the voltage, it has been dropped up to 1.67. Okay, so now it has been completely dropped. Okay, so the only the voltage is get dropped in the series circuit. So if I'm just giving this much amount of charges into the single line circuit, it is a closed one line circuit. It is not having any alternative path to be choose. Okay, if I'm just giving this, this is the complete. It just simply take an example. Okay, so this is the one line, only one pipe. So through this pipe or through this wire, I'm just sending this charges, which is up to 50 electrons of charges. Okay, so it has started to be created. Okay, the electrons have started to move. The conversional current has started to flow. Okay, so it depends on this how much electrons has been sent. So we are going to be calculating the current in amp. Okay, so for example, here we are having the 1.6 milliamp of current. Okay, that much amount of current we are having. So when I'm going to be give this much amount of current, it is completely the single line closed circuit. If I'm giving the 1.6 milliamp of current, it is still remain same up to it reaching this end node. Okay, you can able to get same 1.6 milliamp of current only at the end. In between, mild variation in the pressure might be varies. Okay, depends on the material. If the material is crook, like this kind of material we have been applying, so some area it is narrow, some area it is wider. So if we are choosing this kind of material, it will be the resistance value get changed. Okay, that means it will be affect the voltage. That means pressure get affected, but it will be still remain the current. Okay, so potential difference between the two end, it is dropping some voltage that is going to be varies, but the current it still remains same. Okay, you can able to with the help of this circuit, you can easily understand how it is actually varying. Okay, and yes, so voltage you're going to be add up. I don't know. Okay, and here you're going to be find it out the total resistance, but here you can able to simply see this current is still remains same. So that's what is the common current we have been used, right? So total voltage which is going to be applied in your Ohm's law. Okay, so whatever the parameter which is changed, we just take it as in V1, V2, V3 because voltage is changing, but resistance is also changing, but the current is still remains same. Okay, we can without we can easily find it out the voltage and resistor we can apply into the Ohm's law. Okay, what are the key properties of this one is yes. So what you are going to be understand here this, whenever you are going to be using the series circuit, whenever you are going to be using the series connection connection, you just take a very good example. Okay, Yeah, here you're having some power supply. Okay, this power supply, through this power supply, which is having a, for example, you're just taking a 230 volt. Okay, so these 230 volt is going to be applied in the 3 ohms. So you're just taking a 3 ohms. Okay, there is a 3 ohms there. These 3 ohm means it is house. Okay, so has been connected serially. Okay, this power is going to be come to this one, come to this one. So here you are giving some voltage. Through that, the current is going to be remain same for this 3 ohms. So 1, 2, 3. Okay. Here, what I'm going to be do is I'm just simply cut off this line. Simply cut off this line. What will be happen? There is no current is going to be get flow because it is connected seriously. Okay. At the time, if I'm cut this line, there is no current will be flowing any of the line. Okay. So that is the logic. For example, you just simply see this one. So here, this is how the current is flowing. Here, I'm just cut off this line. Okay, I'm just simply cut off this line. And again, I'm going to be run this one. Would you able to see that there is any current is flowing inside that? No. So it is not even flowing the current through this because it is series connection. Okay. So even we have been cut off one line. So it is completely stopped. The flow of current will be completely stopped. It will be completely affect the entire circuit. So that is what you're going to be understand on this series connection. Okay. I hope you got clear about this point. Okay. Yes. And yes, this is how you're going to be find it out. And where this series connection is going to be applied. Okay. So whenever we want to dropping the voltage, so you just keep it on the mind. Keep it on the mind. Whenever I need to want to drop the voltage, I just go to this series connection. For example, if you just take the LED, okay, LED data sheet of 2 mm. Okay, for example, I've just simply taken this 2 mm LED. Okay, I'm going to be taken this 2 mm LED. Okay, so here you just take one microcontroller, guys. Okay, you are going to be take one microcontroller. So this microcontroller operating voltage is for 3.3 volt to 5 volt. Okay, this is the operating voltage. Okay, operating voltage means so it will be work with this between. So what can I do here? So my microcontroller will be working this operating voltage, but if you just simply see this LED, red color LED, you just taken a very good example called as a red color LED. Okay. This red color, if you just see this red color LED, what is this operating voltage? Because every peripheral which is having some voltage, okay, forward voltage. So that forward voltage only it can able to work on. For example, so if I'm just simply forwarding voltage is to 2 volts, okay. So this scenario, if I'm just simply given this 3.3 volt to 5 volt, what will be happen? So it will be get damage. So it will be get burst out. Okay. So that is what it is going to do. So I can't able to do this. Here you can able to add one resistor meanwhile. Okay. Now we will check that what is the forward voltage and forward current of this resistance. Okay. You just simply open the data sheet, what LED you are actually, whether it is red color, yellow color, blue color, you just check it and simply post it. Okay. You can simply see this one. Yeah. Just scroll down. What is the forwarding voltage? The forwarding voltage is which is minimum to maximum voltage is 1.8 to 2.2. So what is the forward voltage of this LED? It is 1.8 volt to 2.2. So meanwhile, you can give any of the voltage. Okay, it will be works. So just think it very, very small voltage when compared to this 3.3 to 5. So if I'm just directly given this voltage, the LED is not going to be bear this voltage. At the time, I'm just simply using one resistor. But this time, the resistor should be dropping the voltage. Okay, not exactly my current. Okay, because the current is going to easily get vary. So here they have been mentioned the current forward current of 20 milliamp of current. So the current is IF. That means you are going to be check the IF current. That means forwarding current. Okay, so that forwarding current is 0.0 2 milliamp of current, right? So 0.0 2 milliamp of current. Okay, so it has simply taken this value of 2 milliamp of current. Okay, so which is having the value of 0.002 milliamp of current. Okay, so in this time, I just want to be dropping the voltage. I need to drop the voltage. Simply, I just add one resistor here. Okay, how can I find what the resistor will be suited for this one? Easily. We can apply the Ohm's law. Okay, previous class we have been discussed about this Ohm's law. So what is Ohm's law? V is equals to IR. Okay, here I know this one of voltage and current. Okay, so how I can apply the voltages? So I'm going to be find the resistance value. So resistance is equals to V by I. Okay, so I know the voltage and current. But here my voltage value is, you need to be find the difference, okay, because this is a maximum voltage, whether you can able to give 5 or 3.8, that is your wish. Okay, for example, if I'm just giving the 5 volt means you just take the 5 volt, that means it is called as an supply voltage. Actually I'm having this supply voltage, so I'm going to be give this amount of voltage, but I what is my actual LED's voltages, which is 1.8 to 2.2. For example, I'm just taking a maximum voltage. That is called as a forward voltage. Okay. So you're going to be minus with this one. So what is your source voltage and what is your forward voltage? You're going to be minus that value and you will get how much voltage it is going to be get drop. Okay. By using this resistance. So just simply add 5 volt minus of 2.2. Okay, so after you're going to be do this one, when you're going to be do this operation, okay, and divide it by current. Okay, that means forward current. Forward current is which is 2 milliamp of current, that is 0.002 milliamp of current. So when you're going to do this operation, you can able to easily find it out the resistance value. Okay, the resistance value you can easily find it out. That resistance value you are going to be applying this here. Okay, for example, I just getting 330 ohm. Okay, for example, I'm just getting 330 ohm. So you are going to be simply apply this voltage. So that much amount of voltage will be dropped here. Okay, that much amount of voltage will be dropped here. Okay, so that is the easy to understand this concept. Okay, so for example, if you are just getting 115 ohm, okay, what to do if I'm not getting this 115 ohm? So you can just varying the thing. It's not going to be affected that much. So when you're going to be getting 115 or very minute 140, you can add up to 220 ohm or 330 ohm. That is good to go. Okay, so it will be slightly affects the brightness only, affect the brightness of the LED. Okay, but don't go with this 1k ohm or 1000 ohm of resistor. Minute variation will be okay, but it will be affect the brightness of the LED only. You can go with this 330 or 220. If you're getting a 100 sum of value, you just go with this above 100 and you just go with this value. That is not going to be affecting the brightness. Okay, but don't go with this kind of 1k ohm and all, guys. Okay, so it will be totally affect the thing. Okay, because there is no current will be flow. Okay, that means it will completely affects the thing. That means there is no voltage will be completely get dropped. At the time there is no current will be flows. Okay. Yes, so this is important thing you're going to be understand here. So this is the complete series connection. So that's what I've been explained here. Okay. For example, you're just taking a 2 volt, 3 volt you are going to be get. So for example, you're getting a milliamp of current. So 0.02 amp. When you're going to be divided, you will get 150 ohm. Okay, if there is no 150 ohm is you're not having that, you can use 220 or 330 ohm. Okay, so that is cool. Okay, and that's it, guys. So if you want to be finding out the power value, you just use the power formula. P is equals to V into I. Okay, so if you are having a resistance, yes, you can apply the resistance value. So V is equals to I square R. Okay, so you can apply the current and resistance. You can easily find out the voltage. That means your power value. Okay. So that's it, guys.